Okay, what are all the possible class equations we could have that add up to 8? We know that we've got to have a 1. We know we must have a 1. And all the other numbers must be either, well, they've got to divide 8, so there can only be 1, 2, or 4. We can't have 8 because once we've had 1, 1, there's only 7 elements left over to play around with, so we can't have an 8, right? So what are all the possibilities? There's 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. So now let's try and do this systematically again. We could turn these last two into a 2, 1 plus 1 plus 1 plus 1 plus 1 plus 2. We could now also turn these two into a 2, 2 plus 2. We can now turn these last two into a 4, 1 plus 4. Now what could we do? Well, we could have gone from here and we could have instead turned these two into a 2. So if you get 1 plus 2 plus 2 plus 2. And we could also have gone from here and we could have turned these two into a 2. So we get 1 plus 2 plus 4. What? 1 plus 1. Oh, something's gone terribly wrong. Let's see. 1 plus 1, 2, 3, 4, 5, 6, 7, 8. It went wrong right at the beginning. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3. Why didn't anyone stop me and tell me it was all going wrong? 1, 2, 3, 4. 1, 2. Okay, phew, that's better. Actually, you know, this is what always happens with 5-year-olds at school when they're trying to make 5p. They kind of know they've got to do it out of 1p's, and they go 1 plus 1 plus 1 plus, and then they lose count before they get to the end, and so then they write down that that equals 5p. I just did exactly the same thing as them. You see, no cleverer than them. Right. Okay, so these are all the possible class equations for a group of order 8. So we say that that's equal to 8. And then we can ask ourselves the following question. What do all these 1s tell us? Is there something significant going on with all those 1s? And there is, because the 1s tell us when there is an element in a conjugacy class all by itself. And what does it mean to be a conjugacy class all by yourself? So what do the 1s? The 1s tell us who is in a conjugacy class all by themselves. But what does that mean? What does that actually mean? So what does it mean to be in a conjugacy class all by yourself? Well, what it means is that for all, so if A is in a conjugacy class all by itself, it means that for all G in G, no matter how much you conjugate it, you just get back to where you started, right? So this means that basically A commutes with every other element in the group. So another way of saying that is that GA equals AG. A commutes with every other element of G. That's what that means. And so we give this a name because it's sort of useful, and it's called being central. It's connected with being in the center, and it's called being central. Okay. Right. So definition 6.2.6 is this. Let G be a group and pick some element in G, we say A is central, in G. The following is true if for all G in G, GA equals AG. And the set of all central elements is called the center. The center of G, and it's written Z of G. So let's make it completely clear what that is. It's all A in G such that for all G in G, GA equals AG. And it's, you might wonder why it's called Z. Well, Z is for the German for center, which is Zentrum, or something like that. Anyway, right, so that's the definition of center. And we're going to show that the center is a rather interesting object in the group, and that it's always a normal subgroup. So we first need to show, well, first let's investigate a little more what this center is. So there are lots of actually equivalent ways of saying this, and it's useful to be comfortable moving between all of them. So there are various equivalent ways of saying that A is a central element. So we've got the first one, which was just to say that for all G in G, GA equals AG. But we know this is the same as saying for all G in G, conjugating doesn't get you anywhere. Right? Now, this is the same as, if you look at that, that's the same as saying that your conjugacy class hasn't got anything else in it apart from A. A is in a conjugacy class all by itself. So that's saying that the conjugacy class sub G of this element A is just a lonely A all by itself. So what's another way of saying this? Well, another way of saying that, are we going to line up? We're not lining up terribly well, oh well, is that the centralizer, so the centralizer of A is all those elements that commute with A, right? But this is everything. So that's saying that the entire group is the centralizer of A. And another way of saying this is that for all G in G, A is in the centralizer of G. Okay, so this board looks a bit disgusting. I would have preferred it if I had managed to make all these line up, so that was a bit inept. Sorry about that. So these are kind of the other way around from each other. This is saying which are all the elements that centralize A, and declaring ourselves that, oh, every element centralizes A. But now we're saying for every G, A is in the centralizer of it. And this is this one is in fact also telling us that the center is the intersection of all the centralizers. This tells us that the center of G is the intersection of all the centralizers. Because it's precisely all those elements that are in the centralizer of every other thing.